Hello and welcome to today's final lesson on similarity, looking today at using area and volume. To begin with, can you complete the following two questions? The first one includes a proof, so think carefully about your justification for your reasoning. In the second one, the final part of the challenge, you're looking for the perimeter of the trapezium. So think carefully about which side you need to calculate and how you'd go about that. Pause the video now to give yourself an opportunity to try. So, going through the first one with the proof, it's important that you remember that angle ABD is equal to angle BDC as alternate angles are equal. Similarly, angle BAC is equal to angle ACD as alternate angles are equal, and angle BMA equals angle CMD as vertically opposite angles are equal. Therefore, the triangles are similar. With the second part, like we practiced last lesson, draw out the two triangles separately. You are trying to work out the length of AM, which means you want a scale factor that goes from the 6 to the 4. 6 times your scale factor is 4, which therefore means your scale factor is 2/3. I then need to do 15 times the 2/3 to get AM, which gives me that AM is equal to 10. With the challenge question, first step was to draw out your two separate triangles. I need to calculate AC and CD, doesn't matter what order you do that in, but firstly work out your scale factor. In this time I need 6 times my scale factor to give me 10, which means my scale factor is 5/3. I can then very easily work out CD as 8 and AC as 7.5. Like we did in the question last lesson, notice that you only want BC, which means that you need to do AC minus AB, which gives you an answer of 3. Your perimeter then of the trapezium is 4.8 plus the 4 plus the 8 plus the 3, which gives you an answer of 19.8. Today's learning objectives start by finding the scale factor for area and volume of similar shapes. We will then be moving on to finding the area or volume of a similar shape having its lengths, and then doing some problem solving when we're able to use the scale factor between any capacity to find another. This all comes in really handy if you're an architect, for example, who uses 3D models of big projects to give their clients a better understanding of the way a new building will fit in with its surroundings. These models are always similar to the final product, so everything is to scale. To begin to consider scale factors for area and volume, have a look at the two triangles on the board. The purple triangle is enlarged by a scale factor of 3. Can you fill in the blanks to work out not only the missing sides on the blue triangle, but also what the area of the purple triangle and the area of the blue triangle is? Can you spot a pattern from the link between the scale factor for lengths and the scale factor for their areas? As a challenge, if the scale factor for length is K, what is the scale factor for area? What do you think it would be for volume? Pause the video here to give these questions a go. Okay, so hopefully you found that the height was 9 and the width was 12. You remembered hopefully that the area of a triangle is half base times height, so you've got an area of 6 centimeters squared. And for the blue triangle, you've got an area of 54 centimeters squared. Now, if we think back to the question, it was enlarged, the lengths were enlarged by a scale factor of 3. My areas have been enlarged by a scale factor of 9. If the scale factor for length is K, what did you think would happen for the scale factor for area? And how about for volume? Hopefully, you found that if I have lengths which have been multiplied by a scale factor of K, my areas are multiplied by K squared and the volume is multiplied by K cubed. Let's try and put this into practice. Cones E and F are similar. The volume of cone E is 202.5 centimeters cubed. We want to calculate the volume of cone F. So to begin with, we need a scale factor. We want 6 times our scale factor to give us 4, which means our scale factor is 2/3. Now it's important to note that that is only our scale factor for length. So what I'm going to do is write an L here to remind myself. I want to work with volume, so I need to work out the scale factor for volume. Thinking about our notes from the last slide, what that means is we need to cube this scale factor. 2 cubed is 8, 3 cubed is 27. So we now have a scale factor for volume. We want to calculate the volume of cone F. We therefore know we need to do the volume of cone E, which is 202.5. And let's try a harder question. Pentagons V and W are similar. The area of pentagon V is 40 centimeters squared and the area of pentagon W is 90 centimeters squared. Calculate the value of X and Y. Let's start by working out our scale factor. In this question, we know that 40 times my scale factor gives me 90, which means that my scale factor is 90 divided by 40, which gives me 9/4. Again, checking the question, it's important to note that this is the scale factor for area, so I'm going to put an A there to remind myself. I want to calculate lengths, which means I need to calculate the scale factor for lengths, which, remembering from our last slide, is going to be the square root of this, because this is going to be representing k squared. Square rooting everything means I need to do the square root of 9 over the square root of 4, which gives me 3/2. I can then use that information to work out x, because I know that 8 times 3/2 needs to give me x, which means that x is equal to 12. Similarly, working backwards, I know that 18 divided by 3/2 needs to give me y, which means now it's your turn. Using the 2 examples to help you, can you calculate the area of Q and the surface area of U? Pause the video now to give that a go. Let's start with the first question. As you can see, I've got 2 corresponding sides, so I'm going to begin by working out the scale factor for length, which for this one, nice and straightforward, is 4. The question discusses area, so I would like to calculate the scale factor for area, remembering that when the length is k, the scale factor for area is k squared, which means my scale factor is 16. I'm told that the area of P is 10, which therefore means that 10 times 16 has to give me my area for Q, which means that my area for Q is 160 centimeters squared. Now for the second example. This time I know that 10 times my scale factor needs to give me 640. My scale factor in this time is for volume, so I'm going to put myself a V here to remind myself. Now it's your turn. In your books, complete the questions from the worksheet that's attached on Show My Homework. You do not need to print the worksheet, just write your method in your book, please. There is then a challenge. It'd be great to have a few more of you giving it a go. There are 2 triangles on the board that are mathematically similar. Prove that t is equal to x squared plus 2x plus 1. This is the final lesson on similarity. Next week you do have an assessment. So really try your best on these questions and email me if you have any questions. Good luck!